Welcome to class tonight. I do hope that you all had a great day. Now last night and today in class we worked with experimental probability or probability based on data, making data using experiments to figure out data. Something that is part of making of experimental probability is making predictions. Now we predict what is going to be happening based on the data we see. That's a general idea. In reading, okay, you're reading a book, you make predictions based on what you see in the book. In math, exact same thing. We're making predictions based on the data that we see. Now we're going to be practicing using data to be making predictions. Okay? Now I do want to point out right now, it may seem like we actually have almost two different lessons. In fact, if you're looking at page 558, which hopefully you are by now, page 558, if you're looking at it, you see basically one objective on one side and the other objective on the other side of the paper, and really the two objectives don't really meet, okay? They're not really the same or connected other than we're making predictions, okay? So I want to point that out at the very beginning. It may seem like we're doing two different lessons today. We're not. We're doing one lesson, but that's just want to give you a heads up. Now, let's go ahead and very quickly talk about these two ways. So the first one, we're going to be making predictions from probabilities. Okay, so the probability of event times the total number of trials is going to equal the number of predicted successes. Okay, so for example, if I want to know how many times I will win a game, if I know the probability and how often I try it, I can predict the number of times I will be successful at a game. Next one, making predictions from samples. Now this right here, you should recognize this from a couple chapters ago, because that is a proportion. We're going to be setting a proportion and then using a proportion to help us get and help us find the probability. So let's go ahead and get started with making predictions from probabilities. All right, I put the formula right at the very top again. So once again, we're looking at the probability of the event. That's the probability. How often will it happen? Times the total number of trials, how many times it happens, is going to equal the total number of predicted successes. Let's put it to the test. First question. This is example 1 on page 559. It says, in a family with 2 children, suppose there is a 25% chance that both of the children are boys. Out of 72 families, how many are likely to have 2 boys? So the question is, right there, the probability of 2 boys. And so I set it up. Probability of 2 boys. Now I know the probability of a 25% chance of that happening. So I'm going to put it all up. We'll get to that in just a minute. Now it happens, the number of trials is 72. So the number of families, 72 families. And then finally, when we multiply these two numbers together, we get the number of families with 2 boys. So we multiply the probability times the number of families. Now I don't like that the book did this, but it does work. They took 25% and made it a fraction, which hopefully you guys are all familiar with that. 25% is 1/4 of a fraction. Okay, we know that. That's obvious. Okay, you could leave it as 25%, just make it a decimal and multiply. That would be a little helpful. In fact, I'm going to be doing that a little bit later in the video. Okay, so 1/4 times 72 equals 18. So the answer is there are going to be the prediction is there's going to be 18 families with 2 boys. Once again, this is 25% of 72, 18. All right, so that's the first one. Now let's go ahead and practice this one more, because this does take up, I think, a little more work. Okay, let's do one more like this. This, I think, strikes a little more close to home to you guys as well. So, problem is, this is example, this is the check understanding on page 559. At an arcade, Juanita plays a game 20 times. Ooh, that seems like important information. She has a 30% probability. That seems like another important idea. 30% probability of winning each game. How many times should she expect to win? So that's what I'm looking for. How many times should she expect to win? So I'm looking for the probability of winning is going to equal the number of games. So the probability times the number of games, and that's going to give me the number of expected wins. So she plays 20 times. I see that right here. And she has a 30% chance of winning. Now I am going to make it a little simpler on myself. I'm going to make 30% a decimal. And to do that, all you do is 0.30. Okay? So 0.30 times 20 is going to equal 6. You can do that, write it out, whatever. It's going to equal 6. So she can expect to win 6 times. She can expect to win 6 times because she has a 30% chance to winning, and she plays 20 times. 30% times 20 equals 6 times. All right, I'm going to take a little breath because that's the first part. That's the first part. Now, the first part really, I feel, is very, very simple. Just like yesterday, all you're doing is plugging in appropriate numbers. That's all you're doing. I think that makes it a little bit easier. All right, next part of the lesson. All right, now this goes back to the proportion. Remember I showed you guys this on the very first slide. This proportion, we're going to be using that proportion to help solve. So this is example 2 on page 559. It says, a company makes 15,000 toy robots. The company randomly selects a sample of 300 robots for inspection. This sample has 5 faulty robots. Predict how many of the 15,000 robots are faulty. So this is a big problem. Toy companies do this pretty often, actually. They want to make good toys. And so because of that, they have to inspect their work. Okay? So we're inspecting our work. So it says we're going to do, the formula goes like this. Number of my sample. The number of my sample is going to be 5 faulty robots. The total sample is going to be 300 robots. Now here is the total number of toys made. So in this case, they had 15,000 toy robots made. So it's 15,000. And we put our variable here. Now if you're thinking at proportion, the total numbers go at the bottom. The sample of these smaller numbers are going to go at the top. Okay, total at the bottom, and the smaller numbers are at the top. So let's work this out. All right, so remember my goal is to get my n by itself. The way I do that, I can cross multiply. So 300n is going to equal 5 times 15,000. All right, so remember my goal is to get my n by itself. So all I'm going to do is multiply 5 times 15,000, which is 75,000. So I have 300n equals 75,000. So I'm going to divide by 300 to get my n by itself. All right, and I'm going to get, so n is left all by its lonesome. And so n, when I divide this out right here, is going to be 250. So this company can expect to have 250 robots that are faulty out of their total number of 15,000. Okay? All right, I'm going to take another deep breath because this, I think, will take some time to sink in. Okay? Once again, we are simply just plugging in numbers where they go or where they are appropriate, but it does take a little more thought. Okay? All right, let's do one more like this just to make sure we have this down. All right, now this is where we're going to do a similar problem. This is, you check understanding on page 559. All right, blue. Question is, suppose 1,000 toy robots are selected randomly from 20,000 robots. So our total number now is going to be 20,000, and our sample, total sample, is going to be 1,000. Now, 54 are faulty. That's my number in my sample. How many of them are faulty? So that's my variable. So it's going to go like this. 54, that's my number. My total sample is 1,000. Is going to equal, my total number of robots is 20,000. And my variable, I'll put x. Okay? So ladies and gentlemen, this is my proportion. And now let's solve. Remember, we're going to cross multiply. So 1,000x is going to equal 54 times 20,000. Okay? 54 times 20,000. All right, I'm going to pull my calculator here just to make things go a little bit easier. So 54 times 20,000 equals 1,000 try to get this right. Okay, big number. All right, now I'm going to divide by 1,000. And this is actually very easy. I'm just going to cross out some zeros. And so my answer, they can expect 1,080 robots to be faulty. 1,080 robots to be faulty. All right, ladies and gentlemen, once again, I'm going to take another deep breath because I think this is going to take some time to sink in. That is the lesson. It does seem like we have two different lessons tonight, but all we have to do is remember to multiply the probability by the trials or create a proportion. So based on what data we have, we either multiply the probability times the trials or we create a proportion. Your homework tonight is going to be page 560, 2 through 12 even. Once again, page 560, 2 through 12 even. Have a wonderful night, and we'll see you all tomorrow.